I'm not sure if I can.
Go down to the bottom.
Yeah, that works. Thanks, Cindy.
This is Major Tom to ground control. This light pink area is likely Mandy soil series, or the Mandy component of the map unit. So we have the spotted tissue depth here. Up here, we'll use our imagination. I have not actually visited this map unit or this polygon, but let's pretend that that component is Carrollton. Carrollton soil series does not exhibit any evidence of fossilization. So we have the trifecta occurring here of ecological sites. We have a conifer-dominated canopy ecological site, a conifer co-dominant or non-conifer-dominated canopy here, and then absence of conifer and the resulting soil components. Okay, got to figure out. Okay. All right, a lot of the interest behind this ecological site description and some of the soil work that we've done is a result of CASRI. CASRI is the Central Appalachian Spruce Restoration Initiative. And CASRI is a diverse partnership of private, state, federal, and non-government organizations who share a common goal of restoring historic red spruce northern hardwood ecosystems across the entire Central Appalachians. CASRI's vision is of a functioning red spruce northern hardwood forest ecosystem restored across portions of its former range on both public and private lands, with the scale, connectivity, maturity, and other features that provide habitat to sustain and enhance the viability of the many species and natural communities dependent on this ecosystem. And as I said before, CASRI has been very supportive of the use of soils and ecological site descriptions as a tool to guide forest restoration. We've had several field trips where we've talked about this topic. All right, here's the project area. We spent several years, what a long, strange trip it's been, working in this project area. Just for reference, this is Elkins, West Virginia. Here's Bartow, West Virginia. Just kind of bracket in. I know you all, everybody listening in the room would be familiar with both Bartow, West Virginia, and Elkins, West Virginia. Here's the historic extent of red spruce in West Virginia, and I got this shape file, this layer, from the West Virginia Department of Natural Resources, the Natural History Program, and it was Elizabeth Byers who I think created the document, or at least she provided it to me. So the blue is the historic extent of red spruce in West Virginia, and here is where we work. So we're making some progress in understanding the red spruce ecosystem. Okay, some physiographic features of our project area. At the highest elevations in the state of West Virginia, this area is generally composed of mountain ranges oriented in a northeast to southwest direction, with deep valleys intervening. The area of the site terminates in the eastern part in a high escarpment known as the Allegheny Front. Steep slopes are dominant, but level to gently rolling plateau remnants are present. A little bit about the climate. The mean annual temperature is 46 degrees Fahrenheit. On many days in the normal winter, there is no snow cover, but some years the ground is snow covered all winter. Cloudiness is more common than clear skies. About 81 days per year have clear skies. 196 days are cloudy, and the rest of the days are partly cloudy. In valleys, fog is prevalent in summer and fall. The high surface area of the conifer needles likely captures appreciable moisture from fog and may contribute significantly to the moist soil condition. Rainfall is heaviest in the summer and lowest in the fall. During the growing season, rainfall often exceeds potential evapotranspiration. Long dry periods seldom occur. Westerly winds prevail at the higher elevations in all months of the year except August, when southwesterly winds prevail. Damaging windstorms are rare, although we had quite a bad one last year, the derecho, Hurricane Sandy. A warning, the next few pictures may not be suitable for children. The resource concern. Logging during the period from 1880 to 1920 leaves highly flammable slash, eliminates habitat, and often sets a new forest plant community trajectory. I'm going to allow a moment of silence just to take a look at what we have here, and I'm going to talk about it. What we're seeing here is a hill slope denuded of vegetation. And here's a large pile of logs. Perhaps they're hemlock peeled for bark, and the logs just left to rot or burn. Here, suspended on a cable, is a group of logs that have been harvested upslope and they're coming down to here to be loaded on a rail car. Here's a rail. Well, here's right here. But loaded on a rail car on this railway. So in the 1880s and through 1920s, they were quite efficient at harvesting timber. Here's a picture of the original forest. You need to keep in mind that in the 1880s through 1920s, these guys are only 3 feet tall due to malnutrition. No, I'm just joking. They're fairly large trees, and these are, according to the book I was reading, these are spruce trees using these fellas down here. That's kind of a reference of how large the trees are. It's been estimated that from 1879 to 1912, the total cut of lumber in West Virginia was more than 20 billion board feet. This figure is representative of the lumber from 8,500,000 acres of virgin forest, or more than 85% of the total timbered area of the state. The total lumber cut in West Virginia between 1870 and 1920 was more than 30 billion board feet. Ephraim Shea is credited with the construction of the first geared locomotive. By using reducing gears instead of side rods, this locomotive achieved movement on rough, hilly, and sharply curved track. Shea engines could operate a locomotive on track equivalent to animal-powered tramways. Shea engine gave them the ability to get the wood out of some very remote locations. During the 40-year industrial logging in West Virginia, 17 acres per day of West Virginia virgin timber was needed to keep a single mill filled with a steady flow of logs. In 1909, at the peak of lumber operations, there were 83 band mills and 1,441 other lumbering establishments operating in the state. Nearly 1.5 billion board feet were produced during that year. Steam trains were used to access, and move the timber, and cinders from these trains ignited the dried slash from the harvested spruce forest, causing large and intense fires that burned the thick forest floor of the red spruce forest soils. Some fires burned the ground to the underlying stones, eliminating the soil in the seed bank that is important for the spruce vegetation, leaving these sites available for the pioneering northern hardwood species to dominate. The combined effect of cutting and fire resulted in areas that once had a large red spruce component becoming hardwood-dominated forest with little or no spruce. This photo was included just to kind of set your mind at ease. This is current condition. That is a tree growing on a rock. This patch has good structure and composition. The soil is a spottisol, Willdale soil series. The red spruce mosaic forest historically covered approximately 1.5 million acres in West Virginia. Industrial logging and fires reduced that coverage to approximately 60,000 acres. The dramatic decrease of red spruce influenced forests has spurred the efforts to quantify the former extent of red spruce for restoration purposes. Tools that can target restoration efforts include predictive models and witness tree databases. An additional tool is found through soil morphology, chemistry, and taxonomy. Soils may harbor telltale signs of past red spruce occurrence through the presence of spotted materials. In West Virginia, spotted materials are formed by organic acids produced from decomposition and leaching of coniferous and/or ericaceous plant litter, strongly reacting with the soil matrix. The soil chemical condition facilitates the transfer of humus and poorly crystalline aluminum and iron from the surface, the A and E horizons, to lower horizons, the BH, the BHS, or BS horizons. This process is called podulization. Spottisols are identified if the soils made of spotted materials are well developed and meet the criteria of spotted horizon. Spottisols serve as a definitive marker that conifers once existed on the site in our project area. Spottisols develop within cool, humid climates beneath conifers and thick snowpack. Yes, this is Dave Kingsbury showing David Klotznitzer the appropriate way to dig a spottisol. Another example, this is another example of a nice intact conifer patch, has a higher component of hemlock. It is also a spottisol. Historic accounts indicate that red spruce formed nearly pure stands in the high rocky ridges and plateaus where nutrient-poor soils and abundant moisture favored spruce cover over hardwoods. Spruce-dominated old-growth forests in West Virginia and Virginia are rare, but include many dead spruce, making up 36% of the stems and 44% of the total basal area. Annual mortality has been estimated about 1% for spruce fir forests in North Carolina and Tennessee. This is a state and transition diagram for the spotted shale upland conifer forest. This is an approved ecological site description. We're still in the process of correlation. Any and all assistance and comments will be incorporated into the final correlated document. The red spruce and eastern hemlock state. This is the reference community for the site. The site is the spotted shale upland conifer forest. The description is based on historical descriptions, site index data, professional consensus of experienced ecologists, and analysis of field work. Old-growth forests of this type are very rare. Indicators, greater than 30 to 50% conifer canopy cover, red spruce and eastern hemlock, spottisol soil order, and organic matter accumulation, and the occasional occurrence of pholistic epipetons. Feedbacks, red spruce acidifies the soil, forms spotted horizon, and causes development of thick organic horizons. Thick conifer needle moor creates unfavorable conditions for hardwood regeneration. The black cherry, maple, red spruce saplings state. So this is a disturbed state. It's a log state with a cherry seed bank. This community was created by management, logging, and/or man-induced very low-intensity fire. The indicator is less than 30 to 50% red spruce understory, with hardwoods co-dominating or dominating the canopy. Feedbacks: red spruce is suppressed in the understory. Hardwood leaf litter mold inhibits conifer regeneration. Here's a photograph of that state. You can see the conifer in the understory. This is a mid-story conifer here. The log state with beech seed banks, very similar, other than it's beech in the place of black cherry. The tree plantation state. In this area, in the project area, it's typically Norway spruce or red pine. There's the occasional white pine here and there. This phase is a plantation planted by the Civilian Conservation Corps and the United States Forest Service during the 1930s and 40s. These areas were planted to provide timber products, but they do now provide some wildlife benefit. The conifer hardwood ecotone with a spotted distridet, the red maple, red spruce, beech brush, ESD. Mandy soil series recorrelated from the typic distridet. They're now a spotted distridet. The historic plant community composition of the site was relatively stable. American beech, red spruce, and hemlock are long-lived and very shade-tolerant species. Red maple, sweet birch, yellow birch are less long-lived. Natural disturbances in this community are characterized by wind throw of individual trees. Stand replacing lightning ignited fires may affect large patch sizes but occur rarely, 300 to 1,000 year intervals. Beech bark disease, an invasive disease, has altered the plant community. Beech bark disease, a complex affecting American beech, includes both insect and fungal components. The disease passes through three phases: the initial scale front phase, the second killing front phase, and the final aftermath forest phase. During the initial phase, the exotic scale insect disperses through the forest, causing scale-induced alterations to patches of bark. The killing front phase begins 1 to 19 years after the arrival of the scale. Throughout this phase, the scale-modified bark is killed and colonized by species of Neo-Extria, rendering the dead tissue vulnerable to additional decay and fungi. The resulting beech snap and mortality levels may reach 50% in 5 years. Here's the state and transition diagram for the spotted shale upland forest. The following slides are a couple of example states you'll find from this state and transition diagram. The reference state is red maple, red spruce, beech brush state. Now it was difficult for me to include this beech brush scenario in my reference state, but that is the current condition, and that is the state of things for perhaps a foreseeable future. This is the reference community for the site. The descriptions based on historical descriptions, site index dated, old growth forests of this type are very rare. The indicators of this community, they are the result of a beech dieback caused by beech bark disease. Historically, beech would have been a major component of the overstory, with red maple and birch species co-dominating. Red spruce likely would have composed less than 25 to 30% of the overstory. Feedbacks occurring: hardwood cycles soil calcium via leaf litter. Hardwood leaf litter mold creates unfavorable conditions for conifer regeneration. More, it's types of organic forest floors. The tree plantation state, This phase is a plantation planted by the Civilian Conservation Corps in the 1930s and 40s. Here's the logged and burn state with a beech seed bank. You have red maple and beech. There is not an understory spruce component in this state. And this is a beech tree with beech bark disease. All right, so now just briefly talk about some management. Here we have a site that looks like it's a black cherry beech brush site, so it's likely been logged and burned. Using ecological site descriptions, conservationists are informed about appropriate locations for spruce planting and release for restoration. Conservationists can use ecological site descriptions to target restoration efforts and set a trajectory for treatment area composition and structure. So this is a really good example of a site that would be good to plant spruce trees. Here's a site that we found a spottisol. It already contains some canopy cover of spruce, but we found a spottisol, so we want to set this site onto a trajectory of greater than 30 to 50% canopy cover of spruce. So release spruce to increase the conifer composition. Here's a fantastic spruce hemlock site. It has fairly good structure, excellent composition. This is appropriate. This site would be appropriate to leave undisturbed. The West Virginia northern flying squirrel. So we've learned that the impacts of these extractive logging operations went beyond the relatively short-lived logging impacts such as loss of forest cover, lack of mature forest habitat for wildlife, and exposed soil susceptible to erosion. Along with the contraction of red spruce forest itself, rare keystone species, including the West Virginia northern flying squirrel, experienced severe habitat loss due to these changes. Fortunately, some fragmented patches of spruce and spruce hardwood forest did persist in areas that were hard to access for logging or that were missed by the fires, leaving refugia for rare species. The West Virginia northern flying squirrel uses cavities in trees and snags of yellow birch or beech as den sites. Good sites would be the spotted intergrade shale upland forests, occasionally making dray nests in conifers. Site occupancy and foraging sites are associated with conifer-dominated stands. This is a picture of a West Virginia northern flying squirrel using a nest box. So the habitat is so degraded in some areas that they've placed nest boxes for the critters to live in, but it also makes it easier for our species to cuddle them whenever they want to count them. All right, so here we have that mosaic imagery with the red indicating conifer stands in this example. And it is quite likely that this forest was a lot more red or pink in the past. This photograph was actually taken, this area here is a grassland dominated by the Greenbrier limestone. With this photo, I was standing at over 4,000 feet on a ridgetop, a limestone ridgetop, looking down into the valley here, and that is a picture of that valley. So if we had a time machine, went back in time, it's my guess, and we wouldn't just see an occasional spruce throughout this forest, it may have been a dominant feature on the landscape. Any questions? Ken?
Not really a question, but an observation. You're talking about what is seen on the spruce on the landscape here. And you've got the soils information, you've got to back that up now, but it's also important to note that is in agreement with a number of historical accounts of that upper end of the Greenbrier drainage basin. Particular one that I'm thinking about from the 1890s that specifically mentioned the head of the Greenbrier River as being a large
Can you please repeat that?
Ken basically commented that our findings agree with the literature, and as we have learned doing the soil science, old literature is good literature. Is that a fair assessment, Ken? Any other questions or comments?
Jason, this is Sean, and we have an online question, and it is any invasive species problem. Would you like to comment on that?
Yeah, hemlock woolly adelgid is an invasive species. It's a very bad problem. Beech bark disease is an invasive species. It's a very bad problem. Most of your plants, your invasive plant species, occur along roads. So, you'll have some areas of invasive plants, but it's not the major feature of the landscape like it is in many other forests. But beech bark disease and the hemlock woolly adelgid, that's real bad news.
So, part about the northern flying squirrel, you mentioned that they prefer birch for nesting sites. So I just wanted to get some clarity on, you also mentioned they're associated with farms and your spruce stands. Is there a connection between birch being kind of associated with conifer stands, kind of co-located species a lot of the time? Would that be a correct assessment?
The question is yellow birch or birch a species within conifer-dominated stands? Yes. Yes, it is.
You mentioned about the habitat for the farm squirrel. What's significance? I mean, you can't be it with end trees, birch, but with the spruce, source.
Yeah, now, like I said earlier on, I'm not a northern flying squirrel specialist, but my understanding from reading some literature published by Dr. Mark Ford is that the spruce-dominated habitat, or patch, tends to be where the northern flying squirrel spends a lot of time feeding. And that they tend to nest or live in yellow birch or beech cavities.
So basically, they don't prefer the church stands. It's kind of a mix, or at least access to it.
The current understanding is that they seem to prefer the beech and the birch for nesting and the conifer stand for feeding. But in an intact forest with good structure, you would have both beech and you would have birch. So, we only have small patches that are maybe 5 acres in size. The largest one is 50 acres. So our knowledge of the composition of the old forest is quite limited. But using my time machine, I've went back in time, and the composition of beech and birch was significant in a spruce-dominated patch. I really don't have a time machine.
Sean, do you
You have
have
no
any?
more online questions?
I want to thank you, Jason. And one thing I'm...
Okay, so we've reached the end of our second seminar session, but before we go, I'd like you all to point your attention into the upper corner of the slide. This is also a new discovery, something that we've had quite an interest on the Monongahela National Forest. It's a suspected subhuman species, or maybe an evolutionary species, that we talk quite a lot about in the field when we're out there digging these pits. And I'll just see if your eye can find the very unique species that's known to live in the West Virginia mountains. I think it is a Yeti, yes.
It's the southern low mountain subspecies Sasquatch.
Yes.
Yeah, that's me in the hole there.
That's Jason in the hole and then running away in the background. But thank you. So at this point, we will adjourn for lunch, and then we will come back to our third seminar of the day at 12:45, staying on time so that way we can utilize the links within the webinar flyer. Okay, thank you very much.
Okay, Sean, we'll break and I'll dial back in maybe 10 minutes prior to the 12:45 minutes.
Yeah, you gotta put on my
Thank you. And start it up again, too. Thanks, Sean. Okay.